Hello, everybody. Let's go over this Unit 3 Lesson 1 activity. If the figures below are similar with a scale factor of 2 to 3, find the value of x. So from the smaller to the larger, the scale factor is 2 to 3. And we can set that equal. The 42 is a part of the 2 side, and then the 3 is part of the larger side. Now we can find the cross product. 2x equals 3 times 42. And 3 times 42 is 126. So 2x equals 126. So x equals 63. Okay, moving over to number 2. This figure below is similar with a scale factor of 6 to 5. Find the value of x. So 6 to 5, scale factor. X is part of the larger shape, so I'll put it on top, and 28 is part of the smaller shape, so I put it on the bottom. And we'll find the cross product. 6 times 28 equals 5x, and 6 times 28 is 168. And 168 divided by 5 is 33.6. All right, moving on. Okay, if ABC is similar to DEF, find the value of x. Okay, I'm going to write a proportionality statement here. AB, BC, and then AC. And for the second triangle, it would be DE, EF, DF. So everybody equals, all of those parts of the proportionality statement equal each other. And now I'm going to fill in the values from the diagram into my proportionality statement. So AB is right here, and that's x. So I'm going to write an x in. DE is over here, that's 25. And then BC is 28. EF is 20. And I actually don't know anything about AC or DF, so I'm just going to cancel those out for now and solve the proportion I have below. 28 over 20 reduces to 7/5. Maybe that'll make it a little bit faster. 7/5. So I'm going to cross that out and make it 7/5. And now we can find the cross product. 7 times 25 equals 5 times x. 7 times 25 is 175. So x will equal 35. So this is 35. All right, if JKL is similar to NML, find the values of x and y. All right, we'll do a proportionality statement first. JK, KL, and JL are proportional to NM, ML, and NL. And we can substitute into the proportionality statement all the sides. So JK is 40. NM is 16. KL is x. ML is 14. JL is 45. And NL is y. Perfect. So we are going to find x by, well, we can reduce that scale factor. 40 over 16 reduces to 5 over 2. And then x over 14. And we also can find y by using 5 over 2 equals 45 over y. Okay, I'm going to actually solve this slightly differently. I know one of the properties of proportions is if I multiply the left side by something, it should equal the right side. So if I multiply the 2 in the denominator by 7, it equals 14. So to find the numerator, I can do 5 times 7. And 5 times 7 is 35, so x equals 35. And to find y, I'm going to do the same process. 5 times 9 is 45. 2 times 9 is 18, so y will be 18. It's just another way to solve proportions. You don't always have to use the cross product. Okay, so now let's do the same thing here. We're going to make a proportionality statement. Don't have a lot of room in this one. I'll squeeze it in. DE EF DF HJ JG and HG. And now I can substitute into my proportionality statement. DE is 9. EF is 14. And DF is 12. And HJ is 15. JG is Y. And HG is X. All right, so I have my filled out proportionality statement. Luckily, I do have something I can reduce to make my scale factor. 9 over 15 reduces to 3/5. And I can make my proportions to solve for y and x now. So 3/5 equals 14 over y. This one, there's no obvious way to do this, so I'm going to use the cross product. 5 times 14 equals 70. So 3y equals 70. So y equals 23 1/3. And to find y, I'm going to use the scale factor, 3/5, and the fraction 12 over x. Now this one I do notice 3 times 4 is 12, and 5 times 4 is 20. So x equals 20. Excellent. Let's do the last problem here. If KLM is similar to PQR with a scale factor of 3 to 5, find the perimeter of PQR. All right, so they give you the scale factor, and that's 3 to 5. And they give you all of KLM, but we have to find out each side of PQR. So let's do that. And then later I'll show you something interesting about scale factor and perimeters of polygons. Okay. So KLM, KL, LM, KM. And then PQR would be P, Q, QR, and PR. All right, so that's a proportionality statement. And I can fill out all of the numerators, but I can't fill out any denominators, but they did give me the scale factor. So I'm going to break this up into 6 different problems. So KL is 6, LM is 15, and KM is 12. And then PQR is going to be the same. I'm just going to copy that over. PQ, QR, and PR. Now to find each of these, I'm going to use the scale factor as of 3/5 to find PQ, QR, and PR. So 3/5 equals 6 over PQ. And so PQ will equal 5 times 6 over 3. which is 5 times 2, which is 10. So PQ, this is 10. Then 3/5 equals 15 over QR. And I notice in this one 3 times 5 is 15. 5 times 5 would be 25. So QR equals 25. And then 3/5 equals 12 and over PR. 3 times 4 is 12. 5 times 4 is 20. So PR equals 20. Okay, so now we know what all the sides are. We can add them up and find the perimeter of the larger shape. So 20 plus 10 is 30. 30 plus 25 is 55. Now, I said I was going to show you something interesting. I'm going to find the perimeter of LMK. So 6 plus 12 plus 15 equals 33. And then PQR, we found it to be 55. And I want to show you something. The scale factor of KLM to PQR would be 33 to 55, which reduces to 3/5. The perimeters of two polygons that are similar are the same scale factor as the sides, 3/5. So we could have much more quickly come up with this if we knew that, but sometimes you have to be shown it first. So there we go. That was awesome. Good luck in your quiz.